Okay, hopefully this is working. Sweet. Okay, I know this is a cam stream, or CAD stream, though I do want to do a little recap on what's going on right now. Because I don't know if anyone stays tuned to my Instagram, because I do post progress on this. But yeah, just recently I was able to somehow machine the two outer rings for no, the two inner rings for Orbital Impact, my 3-pound combat robot. And when I went to test it, I had an issue with the printed plastic gear slipping in the motor, and yeah, that was definitely an issue that I encountered when I wanted to test it. So, I guess it's time to now start doing the cam for the aluminum version of the drive gear for the ring. Now, I have machined gear before, and let me actually bring that out. Okay, so if you see on my 1-pound version, Mr. Roomba, it does have a aluminum ring. And that, it wasn't too bad machining. It was definitely really inefficient because I did shave that aluminum gear out of a pretty big chunk of stock. So I'm gonna hope I can make it a bit more efficient this time around. I can't really talk at the desk because I don't have my desk microphone set up yet, or kind of unset it up, but I get that working next time. Because I'm hoping the next stream will be me actually testing everything and assembling the 3-pound. So I'll be doing that. But for now, let's start with the CAD stuff. Okay, so here is the CAD for the drive gear. It's pretty similar to my 1-pound version, but definitely a bit bigger teeth. Actually, let me find it. It should be somewhere. I have way too many designs in there. Sweet. Okay, I'm gonna need this because I'm gonna probably mimic some of the toolpaths I used for this gear. There it is. Good. See, look how big of a stock I use for this thing, and I had to shave it all down. Fortunately, I have stock that's relatively the same height, so it shouldn't be that much. And I think I'll be doing contours, getting more comfortable using contours and instead of adaptive stuff. Even though adaptive is a lot more easier on my machine, which is a Shapeoko. But this should work if I do a contour, because I did do a whole bunch of contours for the main ring on the 3-pound. So, and I did not break a bit, which I'm really happy about. Though I did use my cheap bits, but hey, it was good to extend the life of that. So let's see, how did I do this? Since now I'm like, oh my gosh, wow. Okay, see how all that time I spent just machining out all that stock. So yeah, that yellow box is the aluminum chunk I used to make this gear, and that was a lot of stuff to take out. So I'm gonna try to minimize that as much as possible for the next version of this cam, or for this cam here. Let's see. Okay, I did have to do something. So what I did is, when I was cutting this out, let's see, when I did the inner part, I did leave some stock, and I slowly increased the size until I had a perfect press fit. And that's what I'm gonna do for this one again, because I still need to check what the offsets are, or what the deflections are for my machine. But I'll just do this for now. So just leave stock and then slowly take off a really small amount every time until we get a really perfect, or until it's a good press fit, because I don't want to have too tight of a press fit. We might damage the motor. So yeah, that'll be something I'll have to reuse. Now I am just taking out so much material here. I'm gonna try to avoid this. Excuse me, let me get some water. Okay, I should be back. Let's see. Yeah, so I'm gonna try to avoid taking out, like, spending time just taking out all this excess stock, because I am using. See that piece there on the desk? That's that kind of rectangular piece with like some chunks missing. Yeah, I'll be using that. Okay, so yeah, I took a whole bunch of material. I'm gonna try avoiding that. It did leave a nice like outline of the shape of the gear, so I'll keep doing stuff with that. I think I'll stick with an 1/8 inch end mill for the outer part here, because see, I don't think I have that much space, because I need to cut out 2 of these gears. That's also one thing, and cramming it into a stock that can barely fit them is gonna be tight. So an 1/8 inch is just barely gonna pass. Okay, so this is the rebore. So this is when I was slowly taking out material. Let's see, how far did I get to? So I had to go. I should have it here somewhere. Okay, maybe it doesn't, because I was checking. Let's see. Usually I have like stock to leave enabled, and it'll show me how much I have to take off. But I guess I didn't keep that. Oh well. Guess we're gonna have to go in like increments of. Because usually when I'm trying to find the right diameter, I just go -0.05 and just slowly decrease that. But I'll figure it out. Okay, so that's the 1/4 inch tooling. 1/8 inch tooling. What did I do here? Okay, so I'll just. Fortunately, this gear isn't as complicated. Where is it? It's just a cylinder inside. I don't have any of this complex geometry, so that should be a lot quicker. So yeah, that wouldn't be needed. Now this I will have to do. Contouring around the whole part with the 1/8 inch. Let's see, what is that for this adaptive? Oh. Okay, so I have to add this chamfer here because the small ML I used to cut out this tooth profile is really, what do you call it? It's really small. So, and it starts getting wider at this height area, so I have to clear it. Let's see, do I have an example here? I don't. Okay. I do have it on the actual new cam, so I'll show that later. But it wouldn't clear, so I have to create a chamfer so it does clear. Okay, next, that's done. Oh, yeah, here's this. So this is when I'm doing the fine details. See, I did it in layer or passes up. Step overs of, wow, that's really, Now I do want to change the speed on this thing because I was able to crank it up to like 200% speed. So I'm gonna multiply that by 2, the feed rate. Oh, chamfering, yes. Oh, that's a 1/4 inch. Did I use a 1/4? Oh, yeah, I did. I have a smaller chamfer tool now, so I'll be using that. Okay, well, I have an idea of what I have to do now to cut this out, so let's go back to the cam. Where is it? I just have way too many stuff for, too many robot designs. But you can only build so many. Okay, where is it? Pilot gear cam, here it is. Okay, so this is what I was talking about, how I had to add that chamfer, because see how it tapers out here? So for this one, I'm not going to really do much of a chamfer, maybe that's it, just for, just to clean the edges up. But I did model the whole end mill here, so I can make sure I clear that actually, like, pretty well. And yeah, that seems to be working. Oh yeah, so this was talking about, like, I'm using this stock here, but see how close the gears have to be? So, I did measure between here, it is more than 1/8 of an inch. I think it's like 3.175 millimeters. Yeah, 3.661. No, 6, yeah. So that should work if I just do contours around here. Okay. Okay, now I gotta just... This is gonna take a lot of thinking. So let me figure out the height compared to the actual part and the height of this. 4 millimeters. Okay, that's not too bad. Let me make sure the height of the stock is proper. 11.9. Let me get a caliper. Okay, it's not right. This is actually 11.5. So let me bring this down by 0.4. Let's see if that's right. Yeah. Oh, is this actually... Oh man, this stock was meant to be cut. Or these gears are meant to be cut on this stock. Let me measure it, just to make sure. Okay, measure from that to this. Yeah, okay, that's perfect. Sweet, we don't have to do any excess stock machining or like lowering the height of this whole stock, so that's good. Okay, so let's create some boundaries to machine in. Do that, I'm gonna hide that. Let's create another sketch here. Okay, I'm gonna project the inner diameters of these and create like a bounding box. So yeah, the gears are around 245 millimeters. Now I'm gonna offset that by 1/8 of an inch. Because it's, oh shoot. Because it will show me where the contours will be for this thing. Or it'll give me a space to machine down into. Just delete those. I should project these parts as well. I was thinking if I could probably go in there with a 1/4 inch, but if I do, I'd have to do contours into it. But I think it'll be fine. It'll be quicker than just hacking all of this out with a smaller end mill. So I'll be doing that. Okay, with that done, let's go into manufacturing. Okay, no setup yet. Now let's hide the sketch for now. Okay, that's the front. Wait, is that the front really? Oh, the orientation is really messed up on this. Actually, no. I could reference the corner from here. I'm just making. I was just worried that I had to reference a corner here, but okay. I thought this through. Okay, now let's create a setup for this cam operation. Okay, so model will be these two. Let me select it from here. Okay, stock from solid, and I will use this. Now I'm going to reference this corner here. Stock box point that. Sweet, now we got our setup from that. Let's rename it. Let's be organized here. Planet. Call the planet gear. Okay, so think of tooling. I believe. Okay, let me count up from this. So we're gonna need a 1/4 inch. That's 1. An 1/8 inch. That's 2. And a chamfer. No, not the chamfer yet. A 1.5 millimeter is 3. And okay, so 4 tools. 4th one will be the chamfer. So a 1/4 inch, 1/8 inch, 1.5 millimeter, and a chamfer and mills can be used. So let's get started on that. Let's also hide this stock here. Okay, now this is what we're going to need some sketches here. Actually, do I need that yet? Yeah, it's just so. Let's see. See, how will the contour look when I'm done with this? It would be nice to keep a nice surface finish on that, but okay, there's stuff to think about. Now, this is the thing I hate that Fusion did. I can't create a new folder here. What the heck, Fusion? Why did you do this? Is there a new way that I don't know about to create a new folder? Because there goes my organization. What the heck? Is it somewhere here? Where did they put it? Oh, it's all. Why is it up here? Okay, sure. Thanks for making it a bit more complicated. Can I shortcut this? Let's see. Is it here now? Yeah, okay. Why did they reset that? Okay, so let's call this a 1/4 inch cutting. And I believe I'm gonna start off with just doing this inner part first. So let's activate that and see a whole bunch of adaptives. I am tempted to do high efficiency machining or HEM, which has the tool stick in pretty far in there, but takes really small amount of bytes. I could show what that looks like. Let's do it. So we'll be machining all the way down to here. Heights, top height, stock top, select the content. Okay, that's good. Now if I go to, oh yeah, I should leave some stock to leave. 0.5. That's pretty decent. Yeah, we'll do that. Okay, let's do... I really need to organize this a bit more. I did organize it a little bit a year ago, but it's become a mess. Okay, where is it? Here it is. See multiple depths. Oh, great, it adds it. That's sweet. Okay, optimal load 0.2. Wait, is it really 0.254? It is. Wow, that's. Huh. Okay, let's see. So it's 6 in around like 6 millimeters, a quarter inch. It just goes to town on that. How long is that gonna take? 8 minutes? Okay, it's not bad. Oh, it's not bad to me compared to me just spending like 5 hours a day each for those greenhouse on my 3-pound. So that's not too bad. Now, I am worried about this because when I do high efficiency machining, it tends to heat the part up slowly, and I'm not gonna clamp this part down. I plan to do the super glue trick, or painter shape super glue, and that's gonna it'll hold the part real down well, but once it starts to heat up, that's when we have issues. So I don't think we could do this. Let's see, let me figure out the distance. 11. Okay. I'm gonna find a way you could evenly divide this out. Let's go back to regular adaptive. So that was 8 minutes, so if we go back to regular adaptive stuff, or my regular adaptive recipe, which is, here is it? It's somewhere here. I think it's this, yeah. Oh no, it's red. I'm gonna change the depth to 2 millimeters now because I did upgrade the spindle, so that should definitely be able to withstand the deflection a bit more. Okay, let's see what's going on here. So we went from 8 minutes to 17 minutes. Wow. That's gonna take a lot of time. Okay, I have an idea. I could do twice, or I could do this twice. Let's see. First do the high efficiency machining, and then go down to let's see. Okay. Yeah, I'm gonna do the faster method. I'll try it when I'm cutting it. I'll see if it heats up. If the part gets too hot, I'm gonna swap it out with the slower method. Because I could always fall back to that. So let's use this. And then we should be back down to 8 minutes. Yep. It's gonna be like one heck of a lot of noise. Because I've cut with this once, with this style once, and geez, it is so loud. Okay, let's see, so we got that down. Now I'm gonna slowly start knocking out the walls here, because I did leave, yeah, 0.5 millimeter of material left. So let's do another. No, let's not do a yeah, let's not do a adaptive. I'm gonna do a circular, or yeah, I'll just do bore. And with that, I will use the regular. Then, so usually use a 1.5 millimeter step. So I'm gonna mimic the step over into the pitch. Oops, no. Forgot to select that. How are we doing this? Let me minimize this amount of stock left over, because I want to reduce as much deflection as possible on my machine. Let's go from 0.5 millimeter to 1/4 millimeter. And then I'm gonna leave just a little bit of stock left here. Let's do 0.5. How long was all that gonna take? 10 minutes, not too bad. Okay, we got the outer part. Now, we got the inner part. Let's get the outer sections now. Now this is going to be tricky because if I measure the distance between some things... Okay, I'd have to do a contour on this. So... let me go and find the contours. And contour the heck out of this. Okay. So the top height would be up here. I'm gonna leave just a little bit of stock between here so I could finish it up later, because it's gonna look really ugly doing contours. So let's height. So bottom height is just like wait a second. That's not what I meant to do. I meant the bottom to be here. No, I'm gonna give it like 0.2 millimeters. Now let's find my contour recipe. 1/4 inch contour. Okay, is this gonna generate now? No, what's wrong? Warnings. Given them would cause a collision. Oh, wait a second, what's going on? I messed up somewhere. Top height, stock height. Let's just do 1 for now. See what happens. Okay, so that works. Oh, wait a second, why is it digging in too deep? Wait a second, multiple depths. Because 0.38 millimeter, okay. Ooh, okay, so this is bad. See how it just took out a chunk there? That is because it's leading in and leading out. That means that it will swing into that part. Let's see, was it gonna... Oh, wait, you're going too fast. Okay, there it is. Is it gonna show? Yeah, look at that. Let's speed that up just a bit. And that's when you have issues. So, let's fix that. Should be here. Lead in, lead out. Let's remove this, and we're gonna have a ramp into the part. There we go. Look at that. It's gone. Now let's see if we do this on the other side. I did this. Okay, is it gonna get angry at me? No. Oh, wait. Okay, I see what's going on. Let's undo that. I'm gonna duplicate this. And do this one next. So far, we got through all of that. Oh, that's lots of material. Oh yeah. So yeah, we're getting through all this. Okay, that's perfect. Oh. Actually, let me be right back. I think there's someone at my door. Okay, I'm back. So, I was doing these contours here. Let's see. Now, I should be able to do an adaptive from this. Actually, we'll see if Fusion's smart enough to figure this out. I doubt it. Okay, so I will be cutting through this ring, nope, out here to this. And in here. Ooh, it's overlapping. Let's not do that yet. Let's just figure out one side. Bottom, no, let's not do that. Because I want to reach it down to here first. Let's see, and okay. Once again, rest machining on 2D stuff is kind of weird. Let's see if this works. Nope. Wait. Let's just do. Yeah, this is all going to be 6061, I believe. I think that's what that material is. I got it. I just got a whole bunch of scrap from random shops, so we'll see. Okay. Fusion. I don't think I like that. Okay. I'm gonna have to do this a whole different way. Just undo everything. Well, until I get up to here, because I gotta do contours differently. Okay, let's figure this out because it's been a while since I've done something like this. So we're gonna first do a contour all the way down to. Okay, so why metal instead of plastic gears? The way I have the gear interface with the motor bell is I have it pressed in the outside. Or I have the motor bell pressed into the gear, and that surprisingly has been holding up really well compared to my plastic versions, because I don't know if you've seen my other fights that the plastic gears pop out, and so far, like on my 1 pound, the aluminum gear hasn't popped out yet. Fingers crossed it doesn't happen in any future fights, but so far it hasn't. I can demonstrate here too. I really don't think you can hear me here, but maybe you can. But yeah, basically, it's just pressed in here, like that. I don't know if you could have heard me from there, but I don't have a desk microphone, but yeah, it's pressing like that. And I'm hoping, yeah, that holds the gear in pretty well. Plastic is nice though, because you do reduce the risk of grinding down the actual gears in some cases, but so far this should be working fine. Okay, what was I doing? Oh yeah, I was gonna change this. I'm gonna do contour down to here. Oh wait, I'm doing this side. Yeah. Let's change the geometry on this. Multiple passes. Here we go. Maximum step over. Let's not do that. What was it? 0.5? I forgot how to do this. That is way too many step overs. Let's do 3. What does that do? Okay, that's looking a bit better. What's the depth of cut though? Oh, that's not. That's okay. I could change that. Oh, wait. Yeah. Okay, we could do further depth. It's a 2. Okay, it looks like it'll be working. Let me hide that sketch in the background. Oh, you have a question? Oh, go ahead, ask away. I'm just doing a random CAD stream, so nothing much. Okay, yeah, well, hopefully I'll be able to do more events. Right now I'm not really registering anything yet. I'm just prepping. Who knows? I'll do it. I'll probably go to another event and hopefully capture the fights properly this time. Fortunately, my last one had camera issues, so that's why I don't really see much fights from my last event. I do want to do a build video on the 3 pound. That would be interesting. Because there's just so much difference into making it compared to my 1 pound ring spinner, yeah. Just make sure I'm doing these right. That seems right. This is gonna take a long time, isn't it? Let's see. 6 minutes just for that. Oh. Could always walk away from the machine. Can I duplicate that? Do it to the other side. Oh yeah, also I'm doing this twice. So it's definitely gonna take twice as long. It's such a weird path. Well, it is ramping down. Huh, yeah. Makes sense. Make sure my is it doing climb in it? Climb? Yeah. Let me check this is also doing climb. What is it doing? Okay. So that's one. Let's get the other ones. Just gonna duplicate this. So, see, the bottom will start there, and I will do the. I'll have it resume from the last depth, so that will be up here. Oh no, Fusion's angry. What did I do wrong? Wait a second, did I mess up? Oh yes, I did. Wait, so how'd the bottom go down here? There we go. That's looking much better. Eventually I'd like to go to NHRO. Though not the upcoming one. I'm pretty sure it's full already. Okay, yeah, I'm hoping this will be where been a while since I've done this type of toolpath where I'm doing contours around it. And I only have 1/4 inch end mill, so we'll see. Let's change it to the other side. Oh yeah, let me make sure I'm leaving some stock. Okay, so what I was checking is that I'm making sure I'm leaving like 0.2 millimeters of material on this face here, so it could go down again, but I think it'll be fine. I don't think I could care too much about surface finish on this side of the gear anyways, and also it'll be buried in the robot, so you won't really see it that much. I'm just gonna remove that. So that was in clearance. So I'll just set that to 0. Now I gotta do to the rest. Where is it? Oh. Bam, okay. Yep, you can see it reaches all the way down to there now. So that is perfect. How long is this all going to take now? Let's see. 31 minutes, not too bad compared to the 5 hours I spent machining just one side of the ring. Okay, we're getting close to the contour section for the gear part. So that's a good thing. So that should be most of the stuff. I do need to go. I am leaving. Let's see, where is it? If I go down here, I haven't cut through the material yet, and that's because I need more. It's gonna give me more surface area to hold down the part while I'm cutting it, so I'll cut that inner circle out later. So let's also do a. Okay, if I go back to the old cam for Roomba's gear, let's see, I was doing this thing called, I was slowly boring out the inside of this thing till it had the perfect size for press fitting the motor. So I'll probably add that as well. I'm not gonna do contours on that actually. Okay, I'm gonna copy this whole folder and just paste it in here. Say. Okay, I'm not gonna use that. I'll delete that. And then we need to contour to this. So geometry. Wait, aren't you gonna let me select that? Sweet. Okay, heights. This is all messed up. Top height is gonna be top of the stock. Bottom will be. Say what the heck? Bottom will be down there. Right? Wait, can I just do 0? Oh, my sketches are in the way. Let's remove that. There we go. Now, to reduce deflection, I'm going to reduce the pitch to 1mm. It is going to take a lot more time, but it does give me hopefully more accurate diameters. We'll see. I'll slowly knock out the material. Okay. We could minimize all that. Now I need to double check how much I left in this section. Does it do another 4? So I left 0.05. Okay. Let me divide that by 2. So stock to leave, radial. Let's go half of that. Come on, I'll just do divide by 2. I forgot Fusion lets me do that. Yeah. Okay, I'll slowly adjust that later as I'm actually machining it. So that's all the 1/4 inch tooling done. Next up is 1/8 inch stuff. Let's do that. New folder, where is it? I hate how Fusion moved it around. Oh, is it? Why isn't it in my shortcuts anymore? Am I just blind? Where is it? Okay, fine, I'll just do it here. New folder. I don't know why Fusion changed it like that, but they did. Can I rename it? Okay. Okay. Now we're into this. Last time we checked off, we're at this point, and I'm gonna do a contour all around that gear. Okay, so to do that, contours. Now this is gonna be really like ugly surface finish wise because there's gonna be some chipper cutting and yeah, that ain't good. But let's do this. So I'll be using 1/8 inch tooling. Oh no, where is it? 2 fluid aluminum contours, yep. I tried single fluting this contour and it did not work that well. Let's do that. Let's leave some stock actually. Where is it? There. No. Leave 1/4 of a millimeter there. Okay, let's see. Is it gonna generate? Let's go. Oh, that's not good. Wait a second. It's plunging way too deep. I need to add multiple depths. And go point. I think I took it down to 0.3 when I was cutting the ring, so I'll do that. And it's slowly generating because there's so many cuts it's gotta do now. Oh, this is gonna take forever. I'm gonna predict this is gonna take an hour of actual cutting time. Oh. Oh, okay. I forgot something. But let's see how long this is gonna take. 31 minutes. Okay. Now, right now it's trying to cut unnecessary material that's missing, so I gotta fix that. Or material that's already been cut. So we're gonna start it right here. Now, I should start at this face and go down. Why did it go back down to 0? Come on. There we go. That's a lot better. What is going on there? Okay. Huh, that's kind of weird. That is a roughing pass. Oh, okay. We cut it. We cut the time in half by 15 minutes. That's good. Let's save that. Yeah, the roughing is done. Let's do not roughing stuff. So I'm gonna do the contour stuff again, but I will be using the settings for, where is it? Adaptive. No, I don't have it here. No, that's a ball and mill. Oh, I really need to organize this. 2 fluid adaptive. Okay, 0.762. I was able to take it to 1 millimeter. Okay, so we're gonna change our multiple depths to 1 millimeter, and then remove stock to leave. If I can find it. Why's my cursor hand? Okay. Oh, that fixed it. There we go. Now we're getting the so yeah, we roughed it out here, and then now we're cutting it down further more. This might be a bit more inefficient though, but it works. Okay. I think we just need to do the yeah, that's done. Actually, no, wait. I need to have it poke through the material a bit more, because I'm pretty sure I'm gonna leave some material under here if I don't have it do that. So I will go and have it pierce through 0.5 millimeter. Do the same thing for this. Oh wait, did I change it to negative? Just double check. Yep. Let's save that. Okay. Well, that should work. That wasn't too bad. Like, if I'm comparing this right now to like if I do that, look at all those toolpaths just to cut down that stock, and then look at the new stuff now. That's not too much. So much better. How long did this take? Oh, well, that took an hour. Ooh, yeah, that's not good. Oh, at least I'm getting some improvement in cam. So that is done, hopefully. Yep. Okay, next step is to just make sure this is working properly. Oh wait, I have the depth of cut set root. Because it's trying to cut. I just want to do one pass, not two. Let me fix that. I'm just gonna have to change this to 0.3 instead of 5. See if that fix it. Then we can compare. Come on, you could generate. You could do it. Oh, I didn't like it. That didn't do it. Well, I'll just go back to the regular. Yeah, I'll deal with it. How long is this gonna take anyways? 22 minutes. Alright. So since that's done, let's go look into our... where is it? 1.5. Wow, that's it, just this. I'm just gonna copy this over because I have pretty good settings on this. Oh, this was set to 16,000. I was cutting... Just the other day I was using this at 10,000 RPM. Okay. Let's copy that over. Yep. Geometry. Alright. Let's fix it. There we go. It was... Oh, okay, let's have it start up here. And... Exit contours. 2.3, because I'm really stretching the length of the flute here. The tool is only 6 millimeters long, and that's like... Ooh. 5.75 millimeters. Okay, wait a second. Let's fix some stuff. .25. Well, that's generating. Let's speed that tool up because I could cut a lot faster. I was messing with the settings on it and I was able to make it twice as fast, so let's change that. Aluminum tooling, come on, okay. Oh, let me check what tool this was. This was the... Okay, fast contour. Wait, did I already speed it up? Because it's called fast. Oh, I forgot. I should really start putting down notes for this. The 285. Let me check what the other ones were. I was using adaptive. What was this at? 254. You know what? I'm just gonna send it at twice the speed. If it breaks, it breaks, and I'll slow it down. Let's just do that. I have a lot of those smaller animals, so you know what? I guess I could sacrifice one. So let's speed things up. So I'm just gonna do that and just put ×2. Let's see what happens. There we go. Just gonna send it. Now, if I go and reselect that tool, it's going. Come on. Oh, it's taking a long time. Oh, why is it taking so long? Okay. Oh, why did it restart? Okay, I need to fix that. Why is it leading in and out? I need to have a ramp. Yeah, let's disable that so we don't end up crashing into the part. Oh, that's taking so long. Actually, when this is done, while that's happening, let's duplicate this. Because we're nearly done. So what I'm gonna do is, while that's generating, I'm gonna go and have it cut out the center part here because we're technically done here. So let's do that. Okay, now it's gonna start up here. So I'll be generating. What is this doing? What happened? Out of date. Are you serious? No, it's generating all over again. Okay, so what do we got? We got 1 tool, 2 tools, 3 tools. We got 1 more tool to do with it. We got to do the contour or the chamfers. It should be really simple, and then that should be it for the stream. Really got this taking so much quicker than the ring. The ring was really challenging to cam out, but since I've done this before, I'm just copying settings from this thing, but making it so much more efficient. And then I want to compare. I want to compare at the end the time, how long it's all going to take. So while that is going, let's go and where's the new folder thing? I thought I added that. Yeah, it is on my shortcuts. Where is it? I don't see it there. Oops, nope. Alright, no. I'll pin it here. I'll put it down here. I'm gonna use my big chamfer. It's a 3/8 size. So, let's activate that. Hey, is this done? Sweet. How long is this gonna take? Ooh, why is that taking so long? What is going on? Wait a second. That's not good. Wait a sec. Why is it taking an hour? Oh, is it repeating the finishing passes? Like, is it going around twice? That's what I'm figuring out. Like, not by twice, like it's... Like, if I select this, you see 2 lines? Oh gosh, this is terrible. Wait a second. There, you see 2 lines here? I mean, like, it's going around twice on that single line. Let me fix that, that's not good. No? Okay, I'm gonna risk it and go 0.3. So that'll be generating. And while that's going, let's do the last chamfer. And I can do that on a contour. So tools, aluminum tooling, and I need to look for my, let's turn off the filters. Okay, there you go, 6 food countersink. Yeah, I use this countersink on so many things. I put on the drill press, I put on the CNC machine. I think it's getting pretty beat up now. Because I've done titanium on it, I've done aluminum on it. Oh. Okay, let's do these. Okay, offset this by 1.5 millimeters. Okay, that looks right. What's going on here? Jeez. Okay, I'm gonna have to fix that later. I'll fix it later. But there you go. We got the cam done, kind of. Well, the basics. I'll make it more efficient over time. But yeah, that's the rough idea. I can simulate it. Let's just check the machine time. 2 hours. That's okay. Compared to this. Wait. You serious? It's taking. Wait, it's less time? Wait a second. Did I do this right? Wait. Okay, I gotta fix this, because this is taking a whole hour. But I could do it later. Right now, I'm happy to have the basis of this. Even simulate it. Here it is. So yep, we're gonna knock out all that material. If this tool path heats up too much, I'm gonna switch down to the more or less aggressive one. So that'll go through. Then we're gonna knock out all this material here. I do see some ways that we can make this slightly faster. Like, I don't have to take off this much material. I could make it a bit less. But let's speed this up a bit more. Okay, now we're getting to there. Oh gosh. Okay, so see how I'm taking up this much? I don't have to take off that much. I could shrink it. So that'll be for me to do later. So yeah. But I'm just happy I got the basis of this thing down. And even if I did run it, it should work. It'll just take a lot longer than I wanted it to, but it should be fine. Yep, there it goes. It's doing the fine details. Wait, how does this look? That's the 1/4 inch stuff. Oh, wait a second. There's all this red here. Collides with stock. Oh no. That doesn't look good. No, that's more stuff to fix later on. Yeah. Oh, hey, Banjo. What the heck is going on here? Okay, so this is doing the final cutting out. Yep. Let me cut to the next part. This whole chunk. Oh, that's why it's taking so long. What are you doing? Wait a second. It's hopping back and forth. Because I want to just do this whole thing first, and then do the whole thing on the other gear. This isn't alright. Let's speed it up a bit. I'm gonna have to mess around with this a lot more later on. Because this is gonna take a lot more time to figure out. But now what is going on here? Oh, is it because this is hitting that? Let me see. Slow down. Slow down. Oh no, what is it doing? Oh, it's trying to generate all this toolpath here. Or it's trying to sculpt out whatever the heck I was trying to do. It's going. Okay, is it done? Okay, there it is. Okay, what are you complaining about? Let's speed it up a bit. It's not right there. What's it angry about? Collision 32. What happens here? Okay, you can see where it's swinging right here. That's where I'm hitting the tool. I should be fine. The tool's shaped differently. I can even check that. We also save. Nope. Where is it? There. Yeah, see, it's not gonna hit. I designed the whole end mill here too. Should be fine. Oh, plastics. And I haven't even fixed flat spin. It's still there. It has some internal damage. I'll get to it eventually, but right now I'm just focusing on prototyping my 3-pound. Like, oh yeah, even Roomba, I still need to fix it. Its main ring got damaged, so, and by main ring is that it's the plastic ring sandwich with the titanium band in the middle. And I don't remember that. I don't know if you remember that one fight, but one of the fights I fought, you know, that vertical spinner, and that split the ring in half. So that's to be done or fixed. And yeah, I only had one titanium band, so I gotta have to get another one of those cut. And it's so wasteful though, because I need to cut a ring out of a big chunk of titanium plate. Oh, no. Let's hide this. I also don't need that. Okay, well, I think this is it then. Well, yeah, we got the whole toolpath stuff. Well, the basics of it. I'm gonna have to change this a bit. I move that up there. That's one of them. But yeah, that's the the CAD stream, cam stream. I don't know. But yeah, I got the basics of this. So I think over time I'm gonna mess with this slowly and see if I can make it a lot quicker than, like, this thing's gonna take an hour. I gotta fix it. No. I gotta get wire jet cut. It would be interesting to try titanium. Maybe a bit dangerous. Oh, maybe I'll push it, see what happens. But yeah, I gotta get that wire jet cut. Yeah, so I got all this done. So yeah, over time I'll make this more efficient. And yeah, hopefully next time I stream, I do want to stream me putting together the second prototype of the 3-pound. So that would be interesting. But yeah, that's it for the stream. So I'll hope you enjoy this random CAD stream. Yeah. Goodbye. I'll be ending it here.